In this video we're going to use calculus techniques to solve a practical problem. What we have here is a tank, and the amount of metal made to use this tank is 54 square meters. There's no top, so this bit here there's no top there, and the sides are square, but this length is different. And the question is, what's the maximum possible volume of this tank we can find if we're going to use 54 square meters. So let's call this length here x. Because it's a square, that length there is x. We don't know this length, let's call that y. So the total area is going to be x squared. That's this length, that's this area here. There's another x squared on the other side there, so that's an x squared. What about the front? That's x times y. There's an x times y at the bottom. There's also an x times y underneath. So that's 3xy. So 2x squared plus 3xy. So therefore 2x squared plus 3xy equals 54. Let's rearrange that to work out what y is. Y is 54 minus 2x squared divided by 3x. Now we're trying to find the maximum volume, so let's work out what the volume is. Well, the volume is obviously the length times the width times the height, so that's x squared times y. But we know what y is, so it's x squared times 54 minus 2x squared all over 3x. X squared divided by x is 1, so we can write that. We can write v is 54x over 3 minus 2x cubed over 3. And 54 divided by 3 is 18. So it's 18x minus 2/3 x cubed. Now we're trying to find the maximum volume, so what we need to do is to find where the gradient of the graph of v against x equals 0. So let's differentiate. So it's 18, 2/3 times 3, that's 2x squared. So at a maximum point, dv by dx equals 0. If you're not sure about this, remember that we're going to get a graph that looks a little bit like that, and then at the maximum point the gradient is 0. So that means that 18 minus 2x squared is 0, so therefore 2x squared equals 18, so x squared equals 9. Therefore x is 3 or minus 3. Now clearly x cannot be minus 3. X has to be positive, it's a length. Therefore x equals 3. Now you don't know whether that's going to give a maximum or a minimum value, so let's differentiate again. So that's minus 4x. So when x equals 3, d2v by dx squared is minus 12. That's negative, and that means when x equals 3 gives a maximum. So what is that maximum value? Well, we know that v equals 18x minus 2/3 x cubed. So when x equals 3, v is 18 times 3 minus 2/3 of 3 cubed. It's not very good 3, is it? There we go. 18 times 3 is 54. 3 cubed is 27. 2/3 of 27 is 18. 54 minus 18 is 36. So therefore the maximum volume is 36 square meters, cubic meters.